A major lesson that appeared fairly early in the pandemic is that COVID-19 has astonishingly strong risk stratification. If you look at the age distribution of deaths in a country like Austria, for example, we have about 1/10 of the deaths occurring in people who are less than 70 years old. The vast majority of deaths are in people who are old. If you look at the stratification of the risk of fatality for a person who is 80 years old and frail, and a child that's 10 years old, we're talking about 10,000-fold or more differences in risk. In my life as an epidemiologist, I have been working with risk factors of 1.3. In the last decade, I have been working mostly with risk factors of 1.03 and trying to publish these papers in Nature. And many papers are published in Nature with risk factors in genetics or genomics of 1.03. Suddenly, we have risk factors of 10,000, and we don't know what to do with that. We knew what to do with risk factors of 1.03. We don't know what to do with risk factors of 10,000. That seems completely ludicrous, of course. We know also that not only age, but also underlying diseases are making a huge difference. Across different countries, very early on in the pandemic, even in the first wave where we just didn't know what exactly to do, we realized that if you look at people less than 65 and those who have no underlying diseases, the proportion of deaths represented by that majority of the population is tiny. In the range, for example, of Italy, which is closest to Austria, of 0.7%. I think Austria is about the same range. Children and young adults. Some children and young adults did die. Actually, the US did worse in that regard compared to most European countries. However, these are data comparing US, Italy, Portugal, Sweden, Switzerland, and Netherlands, comparing the overall mortality rate and also the mortality in children and the mortality in young adults. You see the tremendous difference that exists. Mortality in children per million, we're talking about something like 0.37 per million in the Netherlands, the highest being in Sweden and US, 4 to 5 per million. And in young adults, we're talking something like 2.9 per million in Switzerland, all the way to 40 per million in the US. So basically, we have a very peculiar situation. We have a disease that is tremendously lethal for very small segments of the population, which are shown here in their representation in a typical European country, the slices with the thick color, and is relatively sparing the large majority of the population, the slices that do not appear with dark color. The most vulnerable is the nursing home population, where many European countries and the US faced major massacres with anywhere between 30 to 70, 80% of the deaths occurring in nursing homes in the first wave and doing a bit better in the second wave. These are data from the second wave versus the first wave for COVID-19 deaths. We tried to see whether there was a shift in the age distribution, because people were saying when the second wave struck last fall that now young people are dying. That was not true. It was just the same. Actually, there was a difference. The difference was that we had fewer fatalities in nursing homes for various reasons. Hopefully because we did protect them a bit better. We knew of the massacres that happened in the first place, so we said we need to do something about it, which seems rational. Or perhaps there was a harvesting effect, and unfortunately we did lose a lot of people who were in nursing homes, and there were not as many available, in a sense, to die from that major infection. This is the third wave, or data on what happened in 2021 after we started using vaccination. And we started with vaccination of the elderly and nursing homes in most countries, with very few exceptions. For example, Denmark and Romania started vaccinating everyone who was clinically vulnerable, regardless of age, but most countries started from the upper age strata, and this is what you compare the deaths in people 0 to 69 versus more than 70 years in 2021 versus late 2020. You see, in almost all countries, with exceptions, Denmark and Romania mostly, you see a shift towards younger people. Why? Because we have huge vaccination coverage very early on in the elderly population. So many of these deaths that would have happened are averted probably because of vaccination. How about the 0 to 69 or 0 to 70 stratum that does continue to have some mortality, actually an increased share compared to the elderly. This is looking at the cumulative COVID-19 deaths in age 0 to 70 for the entire pandemic to date. And you see that UK seems to have done pretty poorly, and Spain has done pretty poorly. Austria has done among the best, with 1 per 10,000 people. UK is 3 times that much, 3 per 10,000 people. So it's heavy loss of life, but it's not the apocalyptic numbers that we were afraid of in the beginning. I mentioned over and underestimation of COVID-19 deaths. This is a very complex mathematical model that I have developed, but this is a nomogram that stems from that. We could easily spend about 3 hours to discuss the equations that go behind it. But basically, it is using infection fatality rate, overall population mortality in the general population, regardless of COVID. The X factor is an attribution correction factor that depends on the prevalence of the disease, on the characteristics of the PCR test, sensitivity, specificity, therefore, along with prevalence, what is its positive predictive value, and the correction of attribution that clinicians may make, who may see someone with a positive test die, but say, no, that's not COVID-19, he died of a car accident, or conversely, may see someone who didn't have a test or had a negative test, but nevertheless says, no, that's a clinical picture clearly, and I need to count that as COVID-19. So basically, if you see red color, that means huge overcounting. If you see orange color, that means substantial overcounting. Conversely, if you see that gray, that means undercounting. Most combinations suggest overcounting of COVID-19 deaths. But there's clearly differences across countries. For example, in Europe, I would argue in most Western European countries, the most likely scenario is that COVID-19 deaths have been overcounted. Conversely, in India, they have been undercounted, and in Africa, they have been tremendously undercounted. In India, not as much as it has feared. If you put the numbers in the model, it suggests that there's a little bit of an undercounting, but not tremendous undercounting that some people suggest. In Africa, I'm willing to take larger correction factors. Infection fatality rate. What is the chance of dying if someone gets infected? This is a paper that I published about a year ago in the Bulletin of the WHO. It collected the data from all the available seroprevalence studies done until that time that were close to a general representative population. And on average, the median across 51 locations was 0.23%, which was much lower compared to our expectations in the beginning of the pandemic. However, there was large heterogeneity, and I show you here the scatter plot as a function of the population COVID-19 mortality in deaths per million. Most of that heterogeneity can be explained away by differences in the age strata of different populations, by whether there are nursing homes with clustering of highly vulnerable, elderly, frail individuals, the management of the disease. We made a lot of errors. We made errors in ventilation early on with very aggressive ventilation of patients who were very frail. We made errors with hydroxychloroquine, which apparently was more toxic, especially in high doses in elderly individuals, and probably other factors. There are other evaluations that have tried to do the same. Some of them, most of them, pretty much agree with these numbers. A couple of them, like the one from Imperial College, suggest higher infection fatality rate estimates. But as I show in that paper that was published 4 years ago, I think that they have tremendous biases. It's a paper 37 pages long, and you can take a look at all the biases that I think exist in these calculations. My best estimate for a global infection fatality rate at the moment is in the range of 0.15%. For Europe and Americas, it's higher. On average, 0.3 to 0.4%. In some countries, it's higher than others. In some time periods, it's higher than others. For community dwelling people, it's about 0.2%. Because as I said, we had a very huge contribution of deaths in nursing homes. For Asia and Africa, it's probably 0.05 to 0.1%. And these numbers need to be adjusted for over and undercounting of deaths that may be different in different locations, and we still have to learn about that. This is looking at the different evaluations that have been done for the age gradient of the infection fatality rate. I have plotted here a study by Levine, the study by O'Driscoll in Nature, the inferences of the US CDC that are based practically, they're just copying the Levine numbers, and an assessment that we did with my team. This is the Axworth, Catherine Axworth has led this effort separately for all individuals and also for community dwelling elderly, which is the blue dot, see that all of these estimates pretty much agree up to about 50 years old, that this is very low. Where we disagree is at the higher age strata. Our estimates, and these estimates agree with O'Driscoll mostly, suggest much lower estimates of infection fatality rate in the elderly strata, without that meaning that the elderly do not really carry the large burden of the disease. How about Austria? There are several studies in Austria, and these are just a few. Probably the one that got the highest visibility was the study done in Ischgl, the ski resort, where the prevalence of the infection was tremendously high. It was like 42%, with only 2 deaths, which translates to an infection fatality rate of 0.25%. National data and data from Vienna suggest that it may be a bit higher, but you also need to account for seroreversion, you need to account for sampling, for correcting for the test. It could be anywhere from 0.2% to 0.6%, and if you look at less than 70 years old, you need to probably divide that by 10. So it would be 0.02 to 0.06% for the majority of people who are less than 70 years old. So what have we learned? We have learned that the infection fatality rate can vary a lot, from 1/5 of influenza, with some uncertainty also what is the IFR of influenza, because we haven't done all these zillion studies that we did for COVID-19 as far as influenza is concerned, but a number of 0.1 has been circulating right and left, to 10 times or more of influenza. If a country or a location gets mostly blasted in its nursing homes and its vulnerable elderly people, the infection fatality rate will be astronomical. But that's very misleading in terms of what's happening to the rest of the population. The infection fatality rate is not a constant number. It is something that can vary tremendously, not just because of the virus, but because of what we do to deal with the pandemic. It's not the gravitational constant. It's not the Km of an enzyme. It's something that can vary from 0 to infinity, well, almost, but with very huge variability. It depends on the case mix, the population structure, who is infected, how people are treated, and many other factors. The good news is that since we know the key determinants, we can tailor our measures to try to minimize it. How do we do that?